we're going to be talking about Java is data. And so the premise is that in some recent releases, particularly kind of with Java 21, there has been a number of new language features have been added that have allowed Java to be written as a data-oriented programming paradigm. And so we're going to kind of go into that in this presentation. And actually, we do a quick hard refresh just to make sure I'm the most up-to-date for this. As mentioned, my name is Billy Korando. I am a Java developer advocate with a little company you might have heard of called Oracle, but don't hold that against me, otherwise I'm a nice person. So a few things. One, important information, please feel free at any point to ask questions. Obviously hear about you learning about data-oriented programming within Java. And so feel free to ask me any questions about anything you want to have. This is only the second time I've done this presentation, so usually there's still a bit of that point where I'm still kind of ironing out some of the kinks and stuff in there. So asking questions kind of helps me know where I should maybe expand or add to this presentation. If you want to reach out, feel free to email me, or also LinkedIn is maybe where I'm guess the most active on social media now. At least that's where I somewhat fairly often have conversations. So that's also a good place to reach out to me. And then you can get a link to this presentation at that link. I'll get it updated here. I've made a few updates to it since what's out there, but I'll get it updated here today or tomorrow. A few other things, if you would like to know more, so we have dev.java. So one thing, I guess you're already here, you know about this, but on there we have a community page where you can find all of the Java user groups that we know about, and new ones are starting quite often. So actually just recently, like Orlando, they just started their Java user group, and so we added it to their page. So like under the community section and so on, you can find that information. So that's very good. It's always good, and everyone here is obviously supporting their Java user group. It's a labor of passion doing all this stuff, so it's always good. If one way you can support it is just by promoting it to your organization, bringing a friend, bringing a colleague out here. That is always very helpful. And actually, that's something that's really kind of recently started happening with JUG. Is recently we had a few people that have been pretty active about bringing out new members with them. So definitely, it does actually help a lot. So consider doing that. Inside.java, if you want to kind of keep up on like the latest of what's happening with the development of Java, you can go there. We just post stories or articles, virtually every weekday on there. Check that out. We also have a YouTube channel. For example, I know like one of the biggest jokes is like Valhalla. When is it coming out? That's like a major change to the object model and healing the rift between primitives and reference types. And anyways, one of my colleagues, Nikolai Parlog, recently posted a video kind of covering that because we released a new early access build on the main Valhalla JEP, which I'll also talk a little bit about what JEP means here in a few moments. And then lastly, our Inside Java podcast. And finally, also Java 1, we're bringing it back again. So we had it earlier this year, back in March, and it ended up being actually really successful. Like, there's definitely times when I didn't think it was going to be so successful. I was really worried that staff was going to outnumber attendees, or was going to feel overly corporate, but it actually ended up turning out really well. Like, I felt it turned out well. I talked with a bunch of people who I know who've been to plenty of other conferences or even run their own conferences, and they thought it went well. They would have given candid feedback if they thought it wasn't good. So it was actually a really good time. We'll be back at Redwood Shores, California, which is in the Silicon Valley Bay Area. You can find out more information at java1.com. Also, it's not too badly priced. I think it's like $400 or $500 is like the initial ticket price, which, again, isn't too bad by any means. Okay, so bureaucracy out of the way. Let's actually get into this presentation. We're going to cover these major topics of what is data-oriented programming, or DOP, DOP. And then I'll get into like the language features that Java has to support it, and then get into designing it, when to use it, Also, this is like a newer section I'm adding about more practical uses of DOP, and then also a little bit of future of DOP in Java. So what is data-oriented programming? So of course we all know what object-oriented programming is, or we kind of been working with it for a while. So we have where you kind of modeling entities and processes through and combination of state and behavior. And kind of what does that look like? So here, we just have like a basic attendee class. And some of the things is that typically with object-oriented programming is you're going to have immutable states. So here we have we're going to be adding and removing from this favorited presentations to this attendee, or using getters and setters, or at least setters here, and maybe also doing things like validating if the email is correct or not. And then of course also we will have inheritance. So we have a workshop attendee. So usually most conferences, they'll have a standard attendee who will be there for the main conference, or you also have an upgraded workshop attendee who will attend workshops, which usually is the day before the main conference happens. And so a workshop attendee will have everything an attendee has, but then also the ability to do workshops. And so maybe also then they would have add a workshop, and then they would have maybe some sort of way of checking if they can do multiple workshops, but you obviously wouldn't want them to sign up for 2 workshops on the same day or at the same time or something, or whatever it might be. You could have some of these things happening. But of course also, like I said, to also fully understand a workshop attendee, you would also need to look at the attendee class, because again, it's extending it and bringing in all the behavior and context of attendee into workshop attendee. So, some of the key things of object-oriented programming is mutable state, abstraction, inheritance. There's also things like polymorphism and more. And of course, this is by no means a presentation that is going to be knocking object-oriented programming. Object-oriented programming, if you're following good programming principles, taking the time, following principles like solid and stuff like that, can be fantastic. And it's also really great if you're doing something where you do need that mutable state, if you are going to be frequently updating and changing it. So if you are writing some sort of an application where people are interacting with it and updating and changing stuff, this is absolutely fantastic. So this is by no means saying forget object-oriented programming, adopt data-oriented programming. This is only comparing the two. So what is data-oriented programming? So it's defined a system by its immutable data that is then acted upon by operations. So really kind of dividing these things up. So the data would be modeled immutably and transparently. You would only be modeling the data, the whole data, nothing but the data. You also want to make sure there can never be an illegal state. So potentially here with object-oriented programming, when you do a bunch of getters and setters, it might be a case you always need to have an email, but if you have a default constructor, no default constructor, and later set an email, then there could be a time when that attendee is actually in an illegal state. And then separating operations from data. So these aren't necessarily hard and fast rules. Data-oriented programming is to touch a little bit later. It's not necessarily new, but it's not as widely adopted, so there's not quite as much intellectual, hey, this is how the best do it, or anything. So like I said, not hard and fast rules, but these are some good guidelines. Again, one of my colleagues, Nikolai Parlak, he put together this really great series. I think it was last year, maybe the year before. Time has lost all meaning, but it's about 7 or 8 articles where he kind of covers all these different characteristics. So I definitely would also recommend checking that out if you definitely want to kind of explore data-oriented programming a bit more as well. But as I said, DOP isn't new. It was initially popularized back in the 2000s for console video game development. And this is a good article covering that. One of the major reasons, and this is also a little bit different from why I'm covering it, because this is also a little bit again, kind of getting into some other things like Valhalla I was touching on a bit earlier, but it was about improving data density within consoles, because consoles, particularly back in that area or that period, often had very constrained hardware, so you had to be very efficient with how you're using system resources. So, also a thing with improving data density, it doesn't just reduce, your memory footprint, but that can also have a lot of benefits when it comes to CPU utilization and stuff like that. So it's not new by any means, and you can kind of read a little bit about it here. But even like almost everything in computer programming, it often goes back to like the 60s, 70s, or 80s. It's kind of crazy just how often that is the case. It goes back to the expressions problem, which is covering the distinction between abstract data types and objects. And it's basically saying, when you're under the code, you have to choose either between polymorphism, where you can add new subtypes, but you can't add new operations, or you can do pattern matching, where you can add operations, but you cannot add new subtypes. So, why are we talking about data-oriented programming now in Java? Like, why is it a thing now? Why wasn't it maybe a case, 5, 10 plus years ago? And well, because that is a series of language changes and updates that have been added recently. So one of them is, where did I put my phone? Can someone hand me my phone? It's right on the table there. Actually, I do want to connect. I'll just use my hotspot real quick. I appreciate that. All right, so one of the first and maybe central features that was added was records, and this was added with JEP 395. JEP stands for JDK Enhancement Proposal. Whenever there is a somewhat substantial change that is being made to the JDK, it goes through this JDK Enhancement Proposal process. If you go to openjdk.org/JEPs and then enter the number, in this case 395, that will bring you to that specific feature. I'll also mention the other numbers for the other features I'll be talking about. And that gives you a lengthy description on what this feature is, some of the actual design history within the JDK on it. So usually when we add a new feature, it goes through this preview process where we preview it, where you can actually work with it, but to work with it, you have to pass in a couple of command line flags about the compile time and runtime, just because that API can change. And then it gives like the goals, the motivation, and so on. So again, if some of these features you want to know more about, this is a good way to know more about it. Obviously, I can't go into the complete depth of all these features, otherwise we would be here until about midnight, and I don't think you guys are quite that flexible of being here that late. But one of the key features of records, and one of the key goals of it, is to be able to allow for the transparent modeling of data as data. One of the nice features of it, or one of the nice things that programs will first experience, is of course being able to define a class within a single line, whereas defining this class otherwise would take dozens of lines to write out. But that wasn't the goal. It wasn't the goal of trying to replace Lombok in of itself, but was to achieve a specific goal of modeling data. A few other things then is you cannot extend a record, so that kind of gets back to that pattern matching where you can't extend subtypes, but you can add operations to them. So it can't be extended. You can't define instance fields, so the only fields that can be within this attendee class is attendee. I can't then say add another field of like middle name within the body of the record that will give a compile time error. All the fields are final, and then also the canonical constructor must be invoked on initialization. So by default, the attendee will create a constructor that has first name, last name, and company, all of the components. These are called components, all the fields though, within that class, that does have to be called. This is again a way of trying to prevent unrepresentable states of like saying like, oh, okay, only first name and last name are initialized. Now, still, of course, you could, pass a null in for some of these fields or something if you don't have any sort of validation for it, but we'll get to that again a little bit more later on. Another important enabling feature is sealed hierarchy. Ours is called sealed classes, but I think sealed hierarchies is a little bit more descriptive. What this does is it allows for a class to define which classes are allowed to extend it. And so here we have, like with conference attendees, it's actually, in this case, I'm using an interface. This is kind of why I try to use sealed hierarchies versus sealed classes. But yeah, so sealed interface, and it's saying the only classes that are allowed to implement, in this case, conference attendee, is a standard attendee, workshop attendee, and speaker. And then here I have record. So while records can't extend other classes, they can implement interfaces. And so, of course, then in this case, all three of these records implement conference attendee, and then they also then in their own ways add all the fields that I'm kind of touching on here, but maybe they also add some additional behavior and fields as well. For example, like a speaker, they're going to maybe have a profile picture, and so like that would be like a URL to the profile picture, as well as maybe what presentations, of course, that they're doing at the conference. Like a workshop attendee, as I touched on a little bit earlier, they would also have like their workshops as well that they would be attending. Yes?
On the sealed interface, do you have to delineate each class that can extend that interface?
Yes.
Or if you leave that off, can it just limit what's in the file itself?
Yes. So that is an important thing that I guess I'm not really showing here, though. So there are two ways of defining a sealed hierarchy. So in this, I'm kind of simulating, like these would actually be perhaps in their own separate classes. If you're using permits, that means you can reference to other files within wherever they might be, saying these are the classes that can extend it. I could also define it within the same source file and without using permits, and then the compiler would be like, okay, these are the only ones that can actually extend or implement this class. You can only choose one though. You can't be like, okay, permits, standard attendee, workshop attendee, and speaker, but then also within the file set, that same file put like organizer, like you have to choose one or the other. So permits is actually, optional. Good question. And then the final major one is pattern matching. And so this was actually multiple different ways it's been added. The first instance of it was, for instance of, which was added in JDK 16, which is at 394. But the more substantive ones was pattern matching for switch and record pattern matching, which was both added in Java 21, which is up 441 and 440. A very nice to have one that unfortunately wasn't in Java 21 is unnamed patterns and variables in Java 22, which is up 456. I don't know if I actually touch. Yeah, okay, I do touch on the unnamed ones. So here, what is really nice about this though is so when you combine sealed hierarchies with pattern matching for switch is. So before, like I covered, there's three different classes that would implement attendee: standard attendee, workshop attendee, and speaker. So when you're doing pattern matching for switch, typically you would have to oftentimes do a default case because it has to be exhaustive. But because I'm doing a sealed hierarchy and because I am covering all the different options with that sealed hierarchy, I actually don't have to include a default case within it. So the first way that's beneficial is that this makes it much easier to read. You're not including this default case where any random thing can happen. Another way this is also very beneficial is if we were to add some other attendee type in the future, then this would actually get a compile error, which of course helps preventing bugs from getting to production. I'm a huge proponent of automated testing. In fact, that's actually one of the presentations I'll be doing in Houston is actually on automated testing. But oftentimes one of the easiest things that can be missed in automated testing is when you're doing something additive, So it's really nice that you can outright prevent a bug from happening because you can't even push to production because you're getting a compile error. It stops you at the very first one. So it adds a really nice safety element to it all. Yes?
I don't understand why null doesn't have to be matched.
Because the compiler can already handle null by throwing a null pointer exception.
But you could match it.
Yeah, you could. So that's also another thing that was added is that you can also, there's the possibility that attendee could be null in this case, You could also include a case null in here and then handle that. And that's also, very nice from a readability perspective, rather than having to wrap this in a if not null and then do this and else, do whatever you do want to do with the null. You can actually handle it within the switch itself. A very nice readability thing.
How fancy can you get into WinClose?
You can do whatever you have access to whatever it is within that class is that you're expanding out. So,
But no static method calls or crazy.
no, you should be able to. So like let's just say like if I was wanting to do like collections or list that is empty, and I could pass in like a workshops thing in there, like that would be fine. Like you could be about as crazy as you could be within like an if statement or within the if check, whatever the normal parentheses. Yes.
With this block of code, if attendee is null, nothing happens.
If attendee is null, then there would be like a null pointer exception that would be thrown.
Oh, okay.
Yeah. So also you can combine record patterns with switch patterns. So like in this case, with if it's like an instance of like a speaker as I'm going through this, then I can take out like their first name, last name, like I'm going to be like updating like the speaker page or something. Then I can take out the first name, last name, company, and their profile picture, and do whatever I need to do with that to display the information. You'll also notice here I have these underscores, and this is the unnamed pattern matching. And so what's really nice for there is, again, if I go back up here a little bit, like you'll see like speaker, they'll have to have things like email and their own favorite person. Like there's a bunch of things that you of course wouldn't want to probably put on that speaker page. And so here you can also do it to where like I will just say like, okay, I don't want to do anything with those, and I don't want to type it out. I will just do underscores in there, and along with just reducing a lot of visual noise on that on this code, it also makes it clear to like whether it's yourself coming back here 2 or 3 months later when you completely forgot what you actually did here, or some future developer that like, oh, it was purposeful, we're not doing anything with these variables, like it was just a deliberate design decision, and it wasn't just an oversight of like, wait, why are we having defining email if we're not using it? It was a deliberate design choice. So that is also, I think, one of the very nice things about the unnamed patterns and variables. I guess let's also just note here, though, that there isn't any sort of performance benefit to this. So if you were to debug this code, like the JVM would assign some like random identifier to these variables. So like they're not like, yeah, there's no performance, there's no security, or there's nothing like that here. It's not like, these things aren't still being assigned or something within the logic of the Java application as it's running. It's just purely syntactic sugar. All right, so what does it mean to actually then design taking these language features and then actually designing a DOP system? So as we mentioned, we're modeling data transparently, so you don't hide states, and so allow operations to have a full view of the data they are acting upon. And so, of course, we get this naturally with a record. When we define a record, this is the entirety of the state of a record. Again, as I mentioned before, a record cannot be extended. So unlike earlier when I was talking with like a attendee, where a workshop attendee can extend off a regular attendee, that's going to be hiding some state up above an attendee from workshop attendee if you're trying to work with it potentially. So records naturally provide this. Now, of course, you don't have to use records to do this. They just work together well. And again, if you're doing this with a normal class, you just need to follow these principles of, not extending off of other classes and, keeping everything within a class. So actually I forgot. Yeah, I do cover that immediately the following. And I guess also another thing with that record are with that is that, you know, you would also want to then define the canonical constructor as well, where all of those fields are set to prevent any sort of mutable state, and of course also setting them to be all final. Yeah, modeling the whole data and nothing but the data. So let's see. Yes, so yeah, so this is about modeling the different alternatives with sealed hierarchies. So like here, like a presentation, like you could have potentially a standard presentation or a workshop presentation. So like you're limiting the world of possible. You're saying these are explicitly what your options are, and then that allows also things like this pattern matching, which I think I'll probably be touching on here in a moment, to also work better. Not only the whole data and nothing but the data. So by default, record will provide some default implementations of equals and hash codes. And what this does is this compares the identity of all the fields, but that might not always be the best. So for like a presentation here, really, you know, probably all we really need is like maybe just an actual ID to compare to, and that would be enough. Some other areas where the default of like hash code and equals may not be particularly useful is if you have like an array or a list or some sort of collection. You know, like that will only compare the reference ID at that collection or list or whatever or array. And that might not be very useful because you could have two arrays where all the underlying all the underlying data is exactly the same, but of course it'll be two different references, and we'll say like, oh, these aren't equal, whereas naturally you think like, oh, well, if all the underlying data within a, you know, one of those is equal, then they should be considered equal. Maybe you don't want it to be that way, but that's at least something to consider when it comes to whether or not you want to depend upon the default implementations of equals and hash codes. Yeah, so also model data transparently. So there can be a tendency sometimes to make data very stringy. So like, you know, I kind of already am doing it here, you know, where I have like string, first name, string, last name, string company, string email, string, and then that can it makes it harder to validate what that data is. It makes it very, you know, flexible in what it can do, but with also that flexibility means that, you know, you're kind of really more opening yourself up to data issues and stuff like that. So probably also here as well, I thought I actually go on to cover that as well, but I guess I don't, is like instead of like first name and last name being both string, maybe I should actually also create a name record as well that, you know, has first name and last name, and then that can also then like handle the displaying of the name as well and all that stuff, which can be good. Yes?
If you're going to cover this later, can somebody be quiet and I'll wait.
No, go ahead. Yep.
The email record there,
Uh-huh.
can you, using records, have validation code
Yes.
as a part of the construction?
Yes, you absolutely can. I think I do actually touch on that here in just a moment, but yeah, still a very good question to ask.
I have a question.
Yes.
So they're held in the standard attendee that email object is a record. Is that possible for that to be a regular object? Or held in a record, does it have to be another record?
No, I mean, after all, I have like string or list in here, and those are normal classes, but yeah. But with records, it's just, you know, when you're handling only like something that just like this pure data, which in this case like would be like email or a name or something, record just works very well for accomplishing that goal. So another thing is, so I mentioned how like records by default, all other fields are final, but it's only shallowly immutable. So for example, like list. So I couldn't reassign it with a different list, but I could add or remove elements to that list, which obviously kind of breaks that immutability principle to it, because obviously adding and removing it doesn't actually change that reference to that list, that reference ID. So you would need to ensure that the data within the class cannot be unexpectedly changed by some client, and you would also want to signal to that client that, hey, you really can't change this data. So you would want to do like defensive copying of this. So here I'm using the sortant constructor. I think it's a sortant constructor, a simple constructor that records apply. But so yeah, what I do is I make a copy of this, and then when you do list copy of, that returns an unmodifiable copy of it. And then also when we return it back, I return back like an unmodifiable list as well. And that way, you know, if that client is trying to like add or make some sort of change to it, they're going to get an exception saying like, so they know that they can't make a change to it. They're not like, hey, I made a change. I added like a new presentation or favorited presentation to this person, but then it doesn't show up. This is why. So yeah, you want to, you know, again, defensive copies, and then also returning something that's unmodifiable, just so that client knows that no, they can't actually change it, and they know that instead of getting like a weird one-time error. Yes?
So all the fields defined in the constructor, the definition of the record, are public and final.
Yes.
So there's a field.
Not necessarily public, or is it public? I can't quite remember. No, they wouldn't be public, they'd be private. Yeah, the fields would be private.
The fields are, but
Yeah, but they create,
generates getters and setters.
it doesn't create setters,
Or
but it does create, and it's not getters, it's accessors. So instead of using the get, it would be like attendee.first name, attendee.last name.
Okay, so
Yeah.
what I was getting at
Yeah.
is like in the constructor there, you can reference the field because you're inside the class. You can
Yeah.
access the private field.
Uh-huh.
And when you define that public method favorite presentations, you are overriding the method that
Yes.
the compiler would generate for you.
Exactly.
Okay.
Yeah, exactly. Yeah, no, great point, pointing that out. So yeah, so by default, like, yeah, exactly as Jason is saying, is like the compiler would already generate a favorited presentations, but by default that would just return the internal copy of that list to whoever's accessing it. But this, I'm also just returning a copy of it, just so there isn't any sort of, they reflect into it, make it modifiable and update it. Like I'm making sure that they can't find some way to underline update it. Yes?
So here, when you're doing the protection functionality, doesn't it increase the memory utilization? Because every time
Yes.
you call favorite presentation, it's going to...
Yeah, I guess there would be an increase somewhat to that memory. So yeah, it wouldn't be a deep copy. It would just be creating like a new list on top of this list that's still all referencing the underlying same objects within it. So like here, like this list of favorited presentations, when I'm doing like the list copy of, it's just creating a new unmodifiable list, but it's not doing a copy of those existing objects. And like also here, it's just creating a new wrapper to reference those objects, not actually copying those as well. But there would obviously be data and CPU costs associated with that. So, you know, you would obviously have to weigh those things depending upon, you know, what your system is doing.
I'm unfamiliar with that. I looked it up too, that constructor syntax with no parentheses. What's that?
That is, I can't remember if it's called the sortant or simplified constructor. So what this is,
All the other constructors?
no, so this is actually because a record is required to have a canonical constructor, this is basically kind of appending the behavior of the canonical constructor.
Only for records.
Only for records. Yeah, it only works for records. And so what this also does then is that, like the compiler will just say this, like, okay, like it will create the normal canonical constructor, but then it will just add this in for like setting that list. But like this also, I don't know if I touch, yeah, okay, I do touch on the validation here, so I'll get to that here as well in just a moment. And we'll see again that, I can't remember if it's called like simplified constructor. Actually, wait, does it actually have?
Does it have a name? It probably has a name.
Yeah, it does. Compact, that's it. Thank you. Yeah, I couldn't.
I finally saw it on your screen.
Yeah. So yeah, that's called a compact constructor, which is this. Yes.
So back to, because it's a shell
Oh.
Basically, have to go through a lot of steps to make sure it's immutable, because if they change one of the elements in the list, it already will affect everybody else. That's true.
Yeah, and so that would also then be about making sure that like this presentation class would also be immutable. And so in this case, within this like presentation would also be considered a record, and so also making sure any of the underlying fields.
The record, the presentation is not a class, but the record that solves the immutability.
Well, no, a sealed interface wouldn't necessarily have anything to do with the underlying immutability of that class. But if I made presentation a record and made sure also like, you know, went through the process of making sure like any of the underlying fields are also deeply immutable as well, you know, that obviously then handles that stack all the way down. So then also an important thing is about making illegal states unrepresentable. So yeah, only allowing legal representations ever to be present in a system to ensure this data should be validated at initialization or as close to the boundary as possible. This is also something that's really important, particularly with records. So one of like Java's like original sins, I guess you could say, well, not quite original, but is serialization. And so the problem, or one of the, serialization was extremely important to the early success of Java, but it's also creates a number of issues. And so like with the normal class, like, you know, public class or whatever you have, like let's say, actually going back a little bit earlier, so I kind of lied a little bit. So like here I'm creating like a normal class and, you know, having like, okay, this is like the only constructor for it. That's a bit of a lie though with serialization. So with serialization, when you do like the Java serialization and all that stuff, it doesn't actually call this constructor. What it actually does is it creates an object and then it like Frankenstein sock puppets it where like it then goes and creates and sets all the fields for it. So like it never actually calls the constructor. So it's possible that like we had signer intendee and like maybe at some point later on, like we added company at some later point. Like it wasn't originally part of it, but there's some, and like let's say company always has to be set. But then we have some existing stuff in the database or wherever it might be that doesn't have a company, and then that can be serialized and set, and then that company can be null, so like that illegal state could still happen with serialization. With a record though, serialization works differently to where that canonical constructor has to be called all the time, so where you have validation within it, which I'll touch on here in just a moment, that can ensure that like an illegal state can't be representable. So
also means we should only do idempotent stuff in the constructor.
sorry, only do validation in constructor.
Well, if you do side effect stuff in the constructor, you're in for it. You're going to
Yeah, exactly. So yeah, but yeah, exactly to what you're talking about. You can do, of course, yeah, validation here. Again, this is using the compact constructor, such as like I'm making sure that like first name, it can't be null. Require non-null, so like if that's non-null, then like that will automatically throw like an illegal argument exception, or if it's blank, then like I'll throw an exception. So like you would just, but yeah, you would do all this validation here within this compact constructor. And then also I guess one of the nice things about the compact constructor, I do seem to have a little, one moment, I have a typo. Before I forget it. Okay. Yeah. There we go. Yeah, there we go. Live coding. So yeah. So also one thing you'll notice is like I'm never actually setting like last name and first name. Like I'm never calling like this first name, this last name. You don't have to do that in a compact constructor by. It will just automatically assume like, okay, this last name is equal to not as last name by default. So you don't have to do that unless you want to do something different like I'm doing here with defensive copying of favorited presentations.
Almost like a post construct in the Jakarta context.
Yeah.
Objects are constructed, you're going to
Yeah.
operate on a constructed object.
Yeah. And then also here, I think someone was like maybe asking a little bit about email address, but yeah, like, you know, within this, you know, I'm checking to make sure the email address is valid, and if it's not valid, then throw an illegal argument exception. Really, actually, I could have just done like, actually, you know what? More live coding, because that's not a good way of actually demonstrating it. There we go. Cool. Yes. So yeah. So like I could do saying like, okay, if the valid, you know, if this is, and whatever this validator is, you know, I don't explicitly show it because obviously validating emails and stuff.
That's what I was saying about side effects. You wouldn't want a validator that goes to the email server and asks it, is this a real email address at this point? Because it's going to reach out over the network, and every time the thing gets deserialized, it's going to go again.
Oh yeah, that's a good point. Yeah, you would probably want to avoid that. Like this would be just using some sort of regex to make sure like does this overall look valid or something like that, or no, that's a good point about side effects. So also again with object-oriented programming. That's one of the things I was showing a little bit earlier with like adding and removing items from it or doing some stuff. Like you can include some behavior sometimes within your modeling of your classes, but like with data-oriented programming, you would want to keep these entirely separate. Already this is kind of violating the mutability principle of it, but the behavior of like adding a presentation, you would not want to do that. You want to be manipulating or doing some sort of substantive business work to your this. But that said, there are cases where you could have. Yes. Okay. This is like an operation that I'm doing here. So like here, I'm managing my presentations, and then I'm going to add it, and then I'm using a switch. It's not pretty.
This is where the memory gets blown. This is because all those fields.
Yeah, I guess a little bit. That could be a bit of an issue. Not too much. It would be making like a second copy. One of the things that this is gonna get right now, I think the biggest issue is it looks really gross. Just because you're having to write out all these fields and then reset all these fields. I'll touch on a little bit later at the end on how this is actually going to get a lot better in future versions. But you can do it this way where you would update it and then create back a new instance of it.
Well, that might answer I was just conceptualizing. Instead of adding to the list, you want to make a copy and then make an entirely new record with that list.
Yeah, so you take an existing record and then you return it, but then with that updated list to it. Or I was like changing like someone's name, like maybe they typoed it, then you have to recreate it and then update that one field.
Changing the data is possible, it's just not as easy as a classical object. You got to create entirely new record.
Exactly, yeah. And like I said, well, I'll show a little bit later, because like I said, this is definitely at least one of the problems. Like if you are doing like a somewhat mutable data a little bit, something like that, like I said, this is really, like I said, gross looking, just because it's just so much visual noise just for doing a relatively simple thing where in object-oriented programming, you'd be like, oh, just set an update or whatever, like 2 lines of code and look very nice and clean and simple. This doesn't look good. But again, I'll touch on that in a little bit later, how that could be better. That said, you can also do something like, well, this is probably not great for like name, but like, if I was to create like a name object, maybe that's something I should change this here. But like if I wanted to make a pre-print of like someone's name, that's fine. Like we're not manipulating data, we're just, changing the presentation of it without obviously, doing any sort of behavior on it. So that would also be okay. So when to use DOP? It's the point of DOP is not necessarily going to be something that's used everywhere. For an overall system architectural perspective, it would be really good for things like ETL. If you're doing just ETLing, exchange, where you're only doing like one simple transformations on it, that is really great for data-oriented. And that's also a little bit why some of this stuff is happening now, because, for some of us older, which, I guess I'm slowly getting into that area as well. Like I got started working on large monolithic applications where you were doing like a lot of work and stuff within the boundaries of the application. But here, like in the early mid 2010s, things like microservices got very popular, where you're more operating at the boundaries of like, oh, okay, I'm getting something in, maybe do some light changes to it, and then I'm sending it off to somewhere else. In which case, that can be nice just to, also maybe a DOP paradigm could work very well there. Also another is if data density is really critical, DOP also has a lot of advantages there. But that said, mutability, if you are making frequent changes to it, so like one of like the monolithic applications I talked about early in my career, like it was like a wizard application where someone was filling out like licenses. So like I started out working at a company that did insurance regulation. So not that insurance is boring enough, but how we're regulating insurance. It's just like boring on top of boring. And it was also one of those things like, what does your company do? It's just like, I don't want to talk about it. Like at least that's like one of the nice things about like Oracle. It's like, oh yeah, their data. Though actually one of the things that's kind of funny or annoying is that recently Oracle bought out a company called Cerner, which is like a huge electronic health records company in Kansas City. So now every time like, oh, I work for Oracle. No, not Oracle Health and like Oracle Prime or whatever. But anyways, that's all besides the point. Yes?
So, everybody has that monolith. Microservices, the new go-to, right? But why, like to me, if I'm writing monolith, I would use records because of data density. Because in monolith, I have to be concerned about my heap and memory size.
Yeah.
So why would records not be advised?
And they could be. I'm just saying like this will maybe some areas where it maybe works a bit better or worse. And actually something I'll also be talking about here also is some a little more practical uses, and that could also be something that I could also update with this presentation as well. But yeah. But anyways, if like mutability is needed, like maybe you're doing a lot of like JPAs everywhere in your application, records don't work well, don't really work with JPA at all. Or again, I was just talking about like this wizard application where we're constantly like updating some like large transaction. Again, this would not really work well within a DOP system. And again, sometimes like a monolithic system, I'm not saying you can't be using it, but it probably wouldn't as easily map onto it or sometime. And again, a lot of times because monolithic applications maybe oftentimes are often doing a lot of updating to various objects within it. I would say also like digital data-oriented programming isn't quite as generally applicable as OOP. Like that's one of the nice things about OOP is that it's just a very broadly applicable program paradigm, and that's obviously why it became kind of, well, so popular and so widely used, is because of its flexibility. So I guess a little bit on my personal opinions, like I wouldn't say fully bought in on data-oriented programming, at least maybe not within the Java perspective. Like I said, yeah, there could be definitely cases where like maybe data is really important. Maybe like certain performance perspectives are really important, but also I think for like a lot of Java developers, like a lot of like it doesn't matter too much necessarily. So like, some of that doesn't necessarily need it. I need to take some more time to really try working with it in practice. That's sometimes the problems of being in developer relations anymore, not really working with things in anger anymore. So like you only get so level of complexity and like, oh yeah, like I had like this perfectly designed scenario for DOP. Well, what do you know? It works great for it, but what happens when you actually start bringing in the weirdness of business and stuff like that? That can be a bit difficult. You need some better definition about when to use it. Like I said, it's not new, but it's not as widely adopted, so there's not as much of intellectual framework as there is when it comes to like was designed, but then like, we also had to add things like, like solid principles to really probably make it much more practical and useful in like a, non-trivial cases. That said, I think some things like the making illegal states unrepresentable and transparently modeling data, I think that's very broadly applicable. Certainly there have been many times where allowing a state to be in an illegal state really bit me, and so it'd be really nice if like within the actual class, like you're making sure every field within it is in some sort of legal state. So that could be something that even if you're not going to fully follow all these other principles, maybe taking the time to actually try to do that to your applications could be very useful. So this is something kind of working on add to this presentations, but maybe also some practical use. So like, okay, this is cool, but like I'm not gonna go, like you're not always starting like a new greenfield application every week or something, or you're not gonna take your existing applications and completely rewrite it to start taking on these principles, but like what are some maybe more practical use cases? And so one of them, I just kind of got from like one of our actual designers of this, was like maybe simulating multi-return values. So of course, like we can't do multiple returns within Java. And so like, let's just say we're calling out to whatever external service, whether this is a database or some other web service or message, whatever it might be. So, we get the response back, call this external service. And of course, that external service could throw an exception for whatever reason. So maybe we just, hey, if it fails, we just handle it one way and handle your error, whatever it might be. Maybe, it throws multiple exceptions for like one, for like an interrupted exception, timeout exception, or of course, there could be some other various exceptions as well. You can handle it. But like the try catches, that can be very visually noisy to look at. So one potential option would be like taking like a sealed interface and like maybe I kind of wrap this in like a safe response. So it doesn't throw exceptions anymore. And then I have like success. Okay, what if it's like interrupted or timeout or something? And then I put this into maybe like a switch case to where I can cover each of these different ones without having all the visual noise of a try catch. It's something I kind of need to practice a little or play with a little bit more here. I was trying to work on a little application here. Past couple of days, I just kept getting distracted with other things, so I didn't get time to really try playing with it. But I think that could be a practical case of, again, maybe kind of reducing some of that visual noise of doing like the try catching, and also maybe it makes it perhaps a little bit more clear and readable as well, saying like, okay, interrupted, how to handle that, or failure. Actually, there's another little coding error that I had there just before I forget. So I think that could be something that could be potentially useful. So getting into the future of it. So I think one of the major changes that's going to really also help with this is derived record creation, or quote unquote withers. And so this allows for the easy creation, or I guess you could almost say in effect, updating of an existing record. So this goes back to that earlier example that I kept describing as gross, where we were going to add like a new favorited presentation. And basically what this does is saying like, okay, hey, this existing standard attendee, just update it with whatever I'm telling it to be changed in here, and then return back with that updated field. So that is going to be, whenever that gets added, that's just going to make that case of whenever you need this, hey, this existing record, we need to update one or two, or whatever field you need to update it, it'll just make it a lot more easier and clearer and understandable and better to work with. Again, performance-wise, it wouldn't really save anything. You would still have the thing of you're copying, a record or something. So like, there would be that memory aspect around it and all. But visually, it'll be a whole lot nicer to work with, and then also be a lot more perhaps expressive as well. Yes?
Do you know, like, if you did with, where you passed the last name string, how it would know it was the last name, not the first name?
So I guess I'm not sure. I can't remember. So like, this is just very basic example of it because it still hasn't been integrated into mainline yet. And so part of the reason why it's also taken a bit of a while for this to be integrated is if they were only trying to do it just to work with records, like it could have been available a while back. But one of the things they want to do is, okay, maybe you started out something as a record, but eventually you need to change it into like a normal class, but you're using withers in a bunch of places. We want to make sure that withers could eventually be added to normal classes at some point in the future, to where if you're in that situation, you wouldn't have to go back and change all your stuff to get rid of all these wither references and stuff like that. Yeah. Yeah, I'm really looking forward. Like, it's going to be a really nice change and update to it. And I think this is also, something that gets back to, so Brian Getz, he is the chief language architect of Java. So like a lot of like these design features, like he has a part in, like he's not the only one doing it. Like there's obviously other bunch of brilliant people he's working with on designing these features. But one of the things he's talked about, and this actually goes back to James Gosling, who was the original, the father of Java, and what he talked about is Java's last mover advantage, where instead of being the first, withers, this isn't a new concept. A bunch of other languages have already implemented this behavior, but we're also then looking at how these other languages have implemented it to see, and whether it's withers or something else, one, is this feature actively being used by the community, or was there like a very vocal group within a community saying like, we want withers or whatever it might be, but then the broader community never really used it, or maybe, a lot of people really wanted this feature like serialization in Java, but then how it was implemented causes a lot of issues.
Like Java modules.
No
comment. Just delete this for now.
So you're saying Java's never going to have async await?
What was that, sorry?
That's the reason, like all these other languages did async await, and they're all feeling the pain.
Yeah.
So that's the last mover advantage. We just won't even bother with that.
Yeah, but looking at these other languages and platforms and seeing like what is actively being used and not, or what's maybe could have been improved upon in that implementation. And so like I think one of them plans also with withers is that like a lot of how other languages do it, it's just like property matching and property updating, but you couldn't really do any arbitrary logic within that wither block. But one of the goals of the wither block is that you could have some sort of arbitrary logic within it to do whatever you want that can maybe be a bit more expressive. So, again, that's an example of like, okay, so this is how someone did it. Here's maybe how we could maybe potentially do it a little bit better based upon their learned experience. That's also why things like Kotlin are so great, because you can see like, oh, hey, Kotlin, this is how it did something that was very useful. And, maybe we can then incorporate that into Java itself. So the other big thing that's also going to kind of touch on this then at one point, and I touched on it a couple of times here, is Project Valhalla. It is kind of generally called like the refactoring of Java. Like again, one of the big things about it is about healing that rift between reference types, like string or anything that you're defining as a class. That's a reference type. But then there's also the primitive types. Like int, long, short, boolean, byte, and so on. About saying, because like there could be cases like, again, the example I'll usually use is like a local, like a date, like today is, it is November 11th. Like you would only need that represented one time within your system. Like you wouldn't need multiple representations of the number 11. You wouldn't need multiple representations of a date, because that's just a single concept or something within your system. So there could be cases where you have like a reference type where you don't really need that identity, and then that gets the things of like helping out with like data density a whole lot there, because there's a whole lot of overhead that comes with that. But I think the important thing, and actually I need to update that to this, is we recently released a new early access version of Project Valhalla. We just did that within like the past couple of weeks or so. So if you're definitely interested in it, check out that out. So I think I link somewhere in here. Well, if like on dev.java, inside.java, we have a link to that video where my colleague Nikolai actually goes through that new early access version of Project Valhalla to kind of talk about it. And no, if you're really interested, I still don't know when it will be available. We are sooner to it, though. It's maybe a little bit like Fusion at times, where it's always, 5 years away or whatever. Anyways, for some following up links, so Brian Getz, he did like a data-oriented programming in Java. He did like an article on InfoQ, I think it was, a couple years back. This is the updated article series, again, from Nikolai that covered this. This is the link to the blog article I talked about. And then also, my colleague and I, Jose Palmar, I would say it was more Jose that designed it, we collaborated on this lab where he actually goes through and refactors a object-oriented programming application to using data-oriented programming practices. So you actually kind of want to see taking like some sort of an application of like, some amount of complexity and how it can be changed to follow data-oriented programming practices. You can follow that, and of course, there's a README within that can step you through that. And it's also been done a number of times, so I think most of like the pain points or if there's something wrong with the documentation that has been figured out by that point. So you should be self-guidable enough. But that said, if you have any more questions, I'll be more than happy to answer them now.
It seems like records would help a lot with concurrent applications, since they're immutable. If you want to change the value, create a new instance of the record with values that everywhere else is represented in the system, they maintain their old state, so you don't have some of those weird concurrency issues. Is that a fair impression? Was that one of the design goals of records? Or?
For concurrency, I'm not sure if that was an absolute central design goal. I mean, I'm sure, they were probably also thinking about that, like Brian and Gavin and the people that were designing it. But I do know, I guess at least in one other way, a similar thing was, so a forthcoming feature would be structured concurrency. And then another thing that's also working with that is scope values, which is also similarly an immutable value. So I'm sure that was probably, at least to some extent, some thought of it. But I don't know how central that was to the design of it. But works together well to have immutability and concurrency for obvious reasons. Yeah. Any other questions? Yes.
I guess I'm curious. It's a Java language feature only, or is it down to the bytecode such that Groovy or Scala or something can also make records?
Yeah, it's a. They should. Yeah, Groovy or Scala or Kotlin should also be able to use records because it is a.
After they're compiled, they are different than classes.
Yes, because there are actual compile time differences. Because, like I said, for example, when it comes to serialization, it actually has to call the canonical constructor. It can't do the Frankensteinian thing of what it does with a normal class.
Thank you,
yeah. Any other questions then, or?
So, given that records can behave like, say, a row in a spreadsheet, would it be, say you wanted to get data from a relational database and want to display it in some sort of Java application, could you hold a list of records and display that in like a spreadsheet style Excel type thing?
Yeah.
And filter it and do relational database type queries on it?
Yeah, you absolutely could. So at least one issue is as I mentioned, they're immutable, and so oftentimes or not oftentimes, but at least sometimes for simple projects, you may use something like JPA, and JPA does not work well because JPA wants immutable objects, so that would be an issue. But yeah, if you're purely just doing view-only representation, that would work really well. Of course, there are ways of eventually withers and stuff of maybe somewhat easily deciding how to change it and stuff, but yeah. Mm-hmm.
Anything else?
All right. Great. Well, thank you everyone for coming out. Thanks for all the great questions. That's always nice to have, active dialogue versus no questions. And it's like, well, all right, have a good night.
All right, thank you.
Cool. All right, thank you.
So much.
Mhm.